In this lesson, we're going to be discussing the double angle formulas and also the half angle formulas. But first, I want you to take a few minutes and pause this so you can jot these formulas down and have them handy when we're going through the course of this lesson. Okay, and the next are the half angle formulas. And if you would do the same. Now there's different representations of the half angle formulas, but this is the one in particular that we're going to choose to use today. So if you would pause it and write these down, and also make sure that these are available to you. Okay, so let's start with our first example. Given if sine of theta is 7/8 and theta is in the interval between 0 and pi halves, now you need to see these as in which quadrant does that put us in. So this is between 0 and 90 degrees. So this is actually just telling us theta is in quadrant 1. Find the exact values of, we're going to work on the double angle of the sine, the double angle of cosine, half angle of sine, and half angle of cosine. So we'll work through all four parts of this problem. So I'll give you a minute to just get this copied before we get started. Okay, and so while you're finished writing it down, I just went and pulled my double angle formula. So first of all, we'll use this formula for A, and we have an option for cosine of 2 theta. So we'll be able to use any of these particular ones, and that's not necessarily going to matter. Now we'll typically use similar ones, but at different times this one may be better or this one may be better. Although if we do the algebra correctly, any of these three should be able to be used and get the same answer. So the first thing we're going to do is we're going to work with this sine of 2 theta, and I'm just going to write that formula down. Alright, now to be able to determine, I need to solve for sine of 2 theta. I need 2 times the sine of theta times the cosine of theta. So what information do we need to be able to calculate this? We need the sine of theta and the cosine of theta. So what we need to do first is some background work and take our information. Well, we know sine of theta, so that's not going to be too bad. But I don't know cosine of theta necessarily. I'm going to keep in mind that theta is going to be in quadrant 1 because it tells us there. And so the sine of theta, so let me just draw me a representative triangle in quadrant 1. Sine of theta, this is your what value over your radius, right? So that's your y value over your r, y over r. So if this is y over r, then this is my y value is a 7. My r value, which is always your hypotenuse, is an 8. How do we find this missing side? Yes, we'll do Pythagorean theorem. So if you will work on that. So I'll say a squared plus b squared equals c squared. Let's let a be 7. We don't know b, and the hypotenuse is 8. So that's going to be 49 plus b squared is equal to 64. I'm going to subtract 49 from both sides. And that would give us b squared is equal to, finishing over here, b squared is equal to square root is equal to 15. Sorry, not square root yet. 15. Now to undo a square, you take the square root. Got ahead of myself. So then b is going to be plus or minus the square root of 15. So what we want to do is come plug in our missing side, square root of 15. Now when we come back over here, we could say 2. What's the sine of theta? It was given to us, so that was good. That's 7/8. But what about cosine of theta? Cosine of theta is your x over your r value, x over your radius. So in this particular diagram that we drew, what is our x value? Square root of 15 over 8. Good. Okay, and now we just want to be able to simplify that. That's going to be 2 times the 7 in the numerator is just going to be 14, and then that's times the square root of 15. And then in the denominator, 8 times 8 is 64. the last thing we want to check for is to see if anything simplifies. So we can see that at least a 2 comes out of this and a 2 comes out of this. So if we simplify that, we would have the sine of 2 theta is equal to 7 square root of 15 over 32. All right, let's move on to part B, which is cosine of 2 theta. Now for part B, we're going to choose to use this third formula. And why do you think that might be a wise decision? Think back to what was the given information in our problem. What was given? The sine value. So this one I'd have to calculate cosine, which I could make a mistake calculating that. This one I would need to calculate cosine. This one only uses sine, which was a given value. So this one has the least chance of me making a mistake. It won't rely on my error. Okay, so let's go ahead and work with this one. 1 minus 2. What did we say sine was on the previous page? 7/8. Good. 7/8 squared. Okay, let's just, as we simplify this, let's work with that right hand side over there. What's 7 squared in the numerator? 49. And what about the denominator? 8 squared is 64. So just taking our time as we simplify here, I'm going to reduce this 2 and this 64. So I'm going to cross cancel right there. There's many ways you can simplify here. That's completely up to you how you want to approach that. And then now you just subtract 1 minus 49 over 32, get a common denominator, and it's going to equal negative 17 over 32. So this is cosine of 2 theta. Okay, so this is going to be our next one. And we're going to write down our formula. So go to your formula sheet, and sine of theta over 2 is going to be plus or minus the square root of 1 minus cosine theta over 2. Okay, so this is defined by theta over 2. So this is a half angle. Let's go back to our original problem and look at this. So first of all, if sine of theta is 7/8 and theta itself, this is just the angle theta, is in the first quadrant, we need to know about the half angle, so theta over 2. So let's just do some scratch work first to just make sure our half angle is in that same quadrant. So for example, we could observe if 0 is less than or equal to theta, which is less than pi halves, and if I divide everything by 2 right there, so what's 0 divided by 2 is just 0. Okay, theta divided by 2 is just theta over 2. And what's pi halves divided by 2? Dividing by 2 is the same thing as multiplying by the reciprocal of 1/2, so that's just saying pi fourths. Okay, so basically this still tells us that our theta over 2 is still in quadrant 1. Which that makes sense. Now in this case we may not have had to do that so much because it may, I mean, if we said if our theta is in the first quadrant and then if we took half of theta, it's clearly going to be in the first quadrant, but we can't make that assumption necessarily at all times. So just doing that observation right there will help us. So now let's go ahead and calculate. To calculate this we need cosine of theta. In this last step, we already solved for cosine of theta for this particular problem, which was square root of 15 over 8. So we're going to use that information for this part. So write that next step out. Okay, so just have this. Let's work in this numerator only first, and let's focus on getting a common denominator. What would be our common denominator in the numerator? 8. Good. So if I put them both over 8, right? Let's see. Okay, this is not over 8, so I would have to multiply this by an 8. Now, this is already over 8, so I'll just have the square root of 15. Okay, then let's just leave our denominator alone for now. Next, I want to be able to simplify. Well, I don't like a fraction within a fraction, so I'm going to multiply the denominator by the reciprocal. The reciprocal of 2 over a known 1 right there is 1 over 2. So whatever I do to the denominator, I'm going to do the same thing to the numerator. Okay, so then that's going to allow these to cancel, which I was hoping for. Then I would have plus or minus the square. 1 times the numerator is just the numerator. So let's be real careful with our notation. And what about our denominator? 8 times 2, which is just 16. Okay, now this square root. What about square root of 8? And can that take, is there a perfect square for the square root of 8? No, so let's leave it alone. Let's leave the square root of 8. And the square root of 15, not anything I can do there, but what about this 16? 4, right? The square root of 16 is a 4, but it's in the denominator, so whenever I pull that out, I'm just going to have a 1/4 out front. So really that's all I can do to simplify. Now, the only thing is we need to have, is it going to be positive or negative? The sign value. What's the sign value in quadrant 1? Positive. Good. So